6.1 Law of Cosines with Jacob Perry, Braden Przanowski, and Mrs. Champagne. Okay. The law of sines states the following. A over sine of A equals B over sine of B equals C over sine C. Okay, example 1 says, use the information to solve the triangle for the unknown sides and angles if possible. If two solutions exist, find both. A equals 19 degrees, A equals 13, and B equals 14. We can draw a triangle to represent this as so. Okay. We can use the law of sines to find the angle measurement of B, just like this.
Which is what?
13 through 30, 33 through 37.
13 through 30?
33 through 37.
Holy moly.
47 through 53. That's all one decimal?
Yeah.
And then just cross multiply
Holy moly. A lot.
to solve for B. And when you do that, you get sine B
Well, let's just say you got your work cut off for you, girl. How's that?
equals, and that equals 4.56 approximately. And then you can go ahead and take your inverse sine of 4.56 to get B equals, B would equal just about 20.52 degrees. And now that we have the angle measurement of angle B and angle A, we can find angle C by taking 180 minus A plus B. And when we do that, we get 180 minus 20.52 and 19 degrees. And by doing that, angle C equals 140.48 degrees. To find side C, we'll take C over sine 140.48, equals sine 19 over, or 13 over sine of 19. And when you cross multiply and do that work, if you have questions and want to see the work, just see Jacob Perry. You get C equals 25.4. And now you have solved this triangle.
No, it's like more navy. it's hard to describe. It's like a mix of navy blue and teal.
Like a dark blue, but a different color.
Yeah. And then it's like all full. And I don't know how to describe.
Since your angle B is greater than angle A, that's when you know you have two possible triangles with what is given. To find your second triangle and your new angle B, you take 180 minus your previous B, which was 20.52, and that gives you roughly 159.48 degrees. Now that you have your new angle B, you can use your given angle A, 19, and add that to your new angle B to find your new C, and that gives you 178.48. Take 180, subtract that, and you get angle C. Angle C equals 1.52 degrees. Now that you have all your angles and two of your given sides, you can find your C length also by using the law of sines. Cross multiply, and you will get C equaling to about 1.06 in length. And now you found your two triangles. First one being B equaling 20.52 degrees and C equaling 140.48 degrees equals 13, B equals 14, and C equals 25.4. And your second triangle is then A equals 19, B equals 159.48, C equals 1.52, and A equals 13, B equals 14, and C equals 1.06.
Okay, so example 2 says, a 10-meter telephone pole casts a shadow directly down a slope when the angle of elevation of the sun is 42 degrees. Find theta, the elevation of the ground. So there's an example in the book. I kind of tried to draw it. If you want to see the real thing, ask Braden about it. So I just labeled everything I got. So the first thing I did, I was trying to find A because I know D is a 90-degree angle and I'm given B as 42. So what I did is I took 180 minus 90 minus 42, and I got A to equal 48. From there, I used the law of sines, and I know that 17 over the sine of 48 equals 10 over the sine of 42 minus theta. Crap. So what I did next is I cross multiplied right here, and I got the sine of 48 times 10 equals 17 times the sine of 42 minus theta. When you break this down, you're going to end up getting 10 times 0.743 over 17 is sine of 42 minus theta. If you take the inverse sine of that stuff, like this, you're going to get negative 16.1, which equals a negative theta. So, finally, you get 16.1 is theta if you divide by a negative 1.